So this week we're going to finish kinematics and switch to forces. Okay, so the place where I usually print the poster, I was caught off guard. They're closed for Labor Day. I thought you were supposed to work on Labor Day. Apparently not. So here's the poster. It'll be there next time. But here's what we're going to talk about this week. We're talking about what forces do and when they do it. Right? Newton's laws. You may have heard of Newton's laws. How to calculate these four. Okay, this is a part of the class I have contracted down a little bit to get to the important stuff later. Remember I told you I was going to cut a little bit of normal intro mechanics out. So for this week, we're just doing 4 forces, not the big list of 12 forces usually you go through. We'll get to some of them later, buoyancy and drag, etc. And you may have heard of free body diagram. Oh my God, free body diagrams. I thought like a shadow was attacking me there. Free body diagrams and net forces, and we'll do kinematics using forces instead of just being given accelerations. And then, of course, the kind of pointless, but just you got to do it, action-reaction pairs. Not really sure why we obsess with those at this level, but it's tradition, so we have to. So let's see, then to get started, let's talk about what we've been talking about. And remember that we were talking about kinematics. So kinematics was, what was it, a mathematical description or something. Here I want to tell you it's how something moves. Right? It's not why, it's just how. Okay? So we did 2 weeks of kinematics. So all the kinesiology majors, I'm sure, were in heaven for 2 weeks. We were studying your major for 2 weeks. Now we're doing dynamics. Oh. So dynamics isn't how something moves, it's why something moves. Yes. That is the difference. This week, we're talking about why. And the answer, of course, is forces. And we love to think about our historical, where did it all come from? At least I do. You have to, because I'm in charge. And the big question, of course, that drove a lot of this thought and a lot of the invention of physics, trying to figure out what is the natural state of motion. That was the big question for 2,000 years, or more than 2,000 years. What is it? And it's very hard to figure out because the forces you're going to learn about today throw off your intuition. You might say, is it rest? When you just set something down, it stays at rest until you do something to it, unless it's on a crooked table. All right? Is it accelerating down? If you leave something alone, it tends to fall down. So maybe that's the natural state of motion. But why down and not sideways? That's kind of weird. Is it constant velocity? Maybe that's the natural state of motion. Because if you have something heavy and you kind of get it going, it kind of tends to keep going, right? I mean, it's like it looks like it wants to go on forever. And you could say, well, eventually it stops, but maybe eventually it's interacting with something else. Oh, yeah. So this was sort of the big thing we're trying to figure out. But it's hard to figure out because things behave so strangely.